Hello all, welcome to the SecurityTube Linux Assembly Expert course and certification. In this video, we will look at data types in assembly language. Now, if you want to just isolate the fundamental data types in this discussion, then that is of course the byte consisting of 8 bits, word 16, double word which is 32 bits, quad word which is 64 bits, and a double quad word which is 128 bits. Now, as far as using NASM is concerned to defining data, couple of important things, right? NASM is case sensitive, and this is something you need to remember while defining your labels and all the other associated things. Now, as far as accessing memory is concerned, NASM uses a very simple way. So let's say I define a message as a series of bytes. Then to move the address of where these bytes are located, you can just go ahead and use the label name itself. Now, to move the values which that label references, you need to enclose the label name within square brackets. Right? This is something we'll use time and again. For more details, check out the NASM documentation. Now in NASM, to define initialized data, we have db to define byte, dw, dd, dq, dt, etc., with which you can define various different data types. Now again, reference the NASM manual. I'll take up some examples at the end of this PPT. If you want to declare uninitialized data, then res or reserve byte, reserve word, which is resw, etc., you can use them. And you also have special tokens such as $, which evaluates to the current line, and a $, which evaluates to the beginning of the current section. Now we already used $, to do a quick trick by which we can figure out the length of the hello world string in previous videos. The other two important ones includes equals and times. Now we've used equals. As far as times is concerned, it is really to go ahead and repeat either data or instruction. So let me jump right into the code and show you a simple example. Now you should have the file datatypes.nasm available for download below the video. It's really nothing but the hello world program with just some additions. The additions are here at the bottom. I've defined variable 1 or var1 as a sequence of 2 bytes 11 and 22 in hex. var2 is basically a dw defined to be 3344. var3 is a dd defined to be AA, BB, CC, DD, and then var4 is a dq basically defined to be AA, BB, CC, DD 11, 22, 33, 44. So really db or defined byte pretty much allows you to define a sequence of byte. dword is basically 2 bytes, dd is 4 bytes, and dq is 8 bytes. Now after that, I've actually shown a use of times in here. Now in this case, I've defined a label called repeat_buffer, and what it does is it pretty much just repeats db0xAA, which is a byte AA, 128 times, right? Fantastic. Now after this, if you remember, we talked about reserving uninitialized data space. So this is where resb, resw, etc. come in. However, these need to be typically defined in a separate section called the BSS, which is specific for uninitialized data. So I've defined a label called buffer, and that reserves 64 bytes in the BSS section. Now apart from this, the only other modification I've made is to illustrate the use of the square bracket to import the value rather than the actual address which the label references. So I'm using var4 for that, right? Everything else is pretty much the same. So let me go ahead and assemble and link this. Let me load this up in GDB. Add a breakpoint to start. Run the program. Disassemble. Of course, we are interested more in the data types, and hence let's just do a quick info variables, and all our variables are listed, right? So hello world is something I've already talked about in the previous video, so I'm going to go ahead and leave it alone. Now var1, now I've opened a new tab so that we can look at data types.nasm just to see what we are wanting to display. So var1 is really a sequence of 2 bytes, 11 and 22. Let's go ahead and check that out. So 2 bytes would be 2xb for display, address var1, and as expected you have 11 and 22 in memory. Fantastic. Now var2 is really basically 2 bytes 33 44 together. So, and if you do a quick info x, you would find all those options. Oops, help x. So first we are displaying a series of byte with b. Now we are going to display a half word var2 with h. So x/xh ampersand var2, and we get 3344. Now we would like to go ahead and display var3. So if you want to do that, change this to var3, and this is going to be w. There you go. And then finally, if you want to display var4, which is 8 bytes long, then we have var4, change the h to a g, and there is var4. Fantastic. Now after this, if you want to look at the series of 128 A's which are there, then we use repeat_buffer. So x 128 x b ampersand repeat_buffer, and we can clearly see all the A's being displayed. Finally, we want to display buffer, which is in the uninitialized data section. So which means the value typically is unpredictable, but typically it's set to 0 by most assembler linker setups. So you have info variables, and we have buffer finally down there. So 64 would be 64 xp ampersand buffer, and you notice the reserved space which is set for buffer. Fantastic. Now let me do a quick disassemble, and what we were really wanting to look at is two things in here. One is to move basically the actual address. If you can go back in here, of var4 into RAX. This is var4, right? And this is the statement which does that. And if you notice the address, of course, even though it's 8 byte long, basically has a lot of zeros in the beginning and finally comes down to 60012E. And if you look up here, that's the address of var4 60012E with all those trailing zeros. And after that, what we are doing in here, which is the second statement, which basically takes the contents of the memory location pointed to by var4 and puts it inside the RAX register, right? This is the statement in here. So let me set a breakpoint for both of these. Let me set a breakpoint in here. Paste it, continue, disassemble, and let me do a quick info registers. Let me do a next instruction. Look at info registers, and clearly RAX now contains the address of var4, right? Here it is. Now in the next statement we are going to fetch the content. So what were the contents, just to remind us? Right, so this was the contents. If you remember, AABBCCDD 11223344, and as soon as we go through the next instruction, look at the registers, you would find that this value has been now loaded inside the RAX register, unlike in the last case where basically we had loaded up the address. So this is really something very important, keep that in mind. Anytime you go ahead and use a label name directly, it implies the address, and when you have the label name inside the square brackets, it means the contents located at that address, right? Fantastic. So that's all I have in mind for this video. In the next video, we will look at EDNS and its importance in assembly language. If you enjoy Pentester Academy, then we'd really appreciate and be thankful if you can recommend us to your friends and colleagues at work or in the InfoSec community. So till the next video, enjoy, have fun, bye-bye.